Hello students, are you here to enjoy the Formula 1 race?
Mister, we want you to spend your weekend making math videos for us. We didn't concentrate in class, so we want you to spend all of your free time to teach us again.
Bruh. Alright, let's do a few of these questions. I've just made a video for year 9, so I don't want to hang around. I'm going to give you a different version of this question. I don't want to give you the actual answer for you. So yeah, so I'm going to give you something like this, okay? 3 over 8 plus 4 over 5. So let's do that. So what we want the denominators to be the same. So I'm going to multiply this by 5 and this by 5. Yeah, and then I'm going to use this denominator to multiply by this side. That times 8, that times 8. Okay, so on the top we're going to get 24. 8 times 3 is 24. 8 times 5 is 40. Plus 8 times 4 is 32. Over 8 times 5 is 40. You add them together and you get 56 over 40. Yeah, so you could leave it as that, or you could call it 1 and 16 over 40, and if you want to simplify that, that's 1 and 2 over 5. Now you can do that on a calculator. This is a 2-mark question, so I would show my working. Okay, next one, it's this type, so I'm going to say, let's say 3 and 1 over 4 divided by, I don't know, 2 and 1 over 5. Yeah, let's do that. So what you do is this, you convert them first into improper fractions. 4 times 3 is 12 plus 1 is 13 over 4 divided by 5 times 2 is 10 plus 1 is 11 over 5. So that's just the same thing, just a different way of writing it. That equals 13 over 4. Remember, if you divide by a fraction, you can just change the sign and invert the fraction, or what you might call keep, flip, change. So we're going to say multiply and invert it, turn it upside down by 5. So your answer is going to be 5 times 13 is 65, 4 times 11, there you go, 44. Okay. If you do this, if you want this as a mixed number, it's going to be 1 and 21 over 44. Alright. So you do the same with that. Next, let's go down. I should be able to do that easily. This one, yeah, it's just calculator job. That, I mean, that's just equal to what? It's equal to 60 over 4, yeah? So then you just do that. Next one, easy. Right, you just have to spot the mistakes. I'm not going to show you how to do that. First few questions, very simple. Okay, straight line. You gotta know that. Make an equation. What do we know about the angle on a straight line? It's 180 degrees. So you're going to get 180 equals blah blah blah, and then you'll get x. Nice. Give a reason for your answer. What's the reason? Angles on a straight line add to 180 degrees. The diagram below is wrong. Alright, what's wrong with that? You should know that. Next one. Alright, straight line. What do we know about a straight line? Angles add up to 180 degrees. Right. We'll continue. Jenna measures all the angles around a point. Her results are 23, this, and this. Explain why these cannot be true. What do we know about the angles around a point? They add up to 300 and... Alright, so check that. This one, it's a quadrilateral. What do we know about all the angle? Some of the interior angles in a quadrilateral are 360 degrees. So find the value for x and give a reason for your answer. Some of the interior angles in a quadrilateral here. Give a reason for your answer. The sum of the interior angles in a quadrilateral add to 360 degrees. Alright, it seems like this alarm is just constantly going to go off. Anyway, explain why this diagram is wrong. Right? What do you know about the angles, the sum of the interior angles in a triangle? Yeah, what do you know about that? So use that to prove that that's wrong. This one should be straightforward. What do we know about the angles around a point? Angles around a point add to 300 and blah blah blah. Okay, this one. What stands out to you straight away with this question? To me, it's that and that. We parallel lines, right? Yeah. So in reality, they just continue like this, don't they? They just continue like that. And look, and then you've got these other lines. They're cutting across the parallel lines, aren't they? What do we know about lines that cut across a parallel line? See this kind of Z shape here? See this Z shape? What do we know about lines that cut across a parallel line? The alternate angles are equal. The co-interior angles are equal. So that plus that equals and here this line also cuts across these parallel lines. So what do you know about that plus that? So you're going to have to use that fact. You're going to have co-interior angles here and here, and then you need to find what's the size of the angle marked x. Alright, well if that's that and that are co-interior, aren't they? So what do they add to? And then you just need to find out. What do you know about the angles in a triangle? They are 100 and they add to 180 degrees, right? Next, just say what you see, really. Do we have vertically opposite angles here? Maybe. Oh look, I wonder will this help us? That. These are parallel lines. We have two parallel lines. And you have that Z shape again. See that Z shape there? That Z shape. So what do you know about that angle and that angle? You'll know something about that. And then you should be able to get this angle. And then that should give you that angle. And then you should be able to get X angle on a straight line. Right. This one, you have to fill in what you know. Yeah? What do we know? Oh, look. Something jumps out once again. Bang, bang. Oh, look at that. We have that Z shape once again. Z shape. Yeah. So what do you know about that angle and that angle? There's some relationship there, isn't there? They're on opposite sides and opposite ends. So you should... let's see. You should know that them and them, that and that, they have a relationship, okay? What else can we get here? We know that, and that. Well, what do they add up to? So you should be able to get that. That'll give you something down here. And then you know the angles in a quadrilateral add to 360, so that should give you X. Okay, I can't go through every question, and I don't want to give you the answers. Alright, straight away again, something jumps out here to me. What do we have? Parallel lines. So they're just going on forever, basically. Oh look, you have this thing that's cutting across that. So you have this giant Z shape. You have this giant Z shape, right? So what do you know about that angle and that angle, for example? You know what I mean? Or what do you know about this angle and that angle? What do we know about these are inside the parallel lines, aren't they, these two? So they'll have a relationship. This and that will also have a relationship. Now read the question. BC and ABD are isosceles triangles. So both triangles are isosceles. Yeah? So you know that side and that side are the same? Yes? And then you will know something about that and that side. So make sure you read the question, because sometimes the diagram doesn't give all the information. And you have to find the size of Y. You should be able to do that. You should be able to do that. If that's isosceles, well, what's that and that going to be? Yeah? And then you're going to use some kind of relationship between these two angles. No, you're not, because these are not alternate. Let me see. So, yeah, sorry. Yeah, this angle here and this angle here, there's going to be some kind of relationship. Yeah, it's going to be like alternate, corresponding, or co-interior. So check that out. Again, jumps out is the parallel lines. We have two Z shapes here. So we'll do the first one. We have this, anywhere you have this Z shape, you have parallel line. So there's going to be a relationship between the angle here and this angle, that angle and that angle. There's going to be a relationship. And then you have the same on this side. It's kind of like a reverse Z. So there's going to be a relationship between that and that, isn't there? And then that and that. You should be able to figure that out. Okay, this is good. The second I see this, yeah, start filling in. There's another Z. It's like a reverse Z. So that we can always work off that. So what do we know about that angle and that angle, or that angle and this angle? Start filling stuff in. Do we know that angle? I think everybody in the class should get that. Okay, and then that'll help you find X. Should be pretty quick actually. Alright, wow, holy moly. Not as hard as it might look. We have a lot of information here. Yeah, we have parallel lines, and then we have isosceles triangles. So that's some good information. Alright, how are we going to do this? Alright, so the first thing you should see, you have parallel lines, and you have that, or sorry, we have that Z shape again, don't we? See it here? This Z shape. Yeah, see it there? That's a terrible drawing. But anyway, you can see what I'm talking about. So there'll be a relationship between this angle and that angle there. And then, let's see. My pen is going a bit crazy here. Right, just bear with me a second. I'll just have to use my mouse. So that angle and this angle down here are going to have some kind of relationship. That should help you fill that in. It's an isosceles triangle, so what do you know about that angle? Yeah, and then that should be help you get this angle, same on the bottom, and that will help you get X. Alright, so we'll continue down. So, I mean, I can't go through every question. You've, again, jumping out to me on this isosceles, that's information. So that'll tell you how to get the angles. You should be able to get all the angles in this. You'll be able to fill in that missing angle, and then you'll be able to get X. Right. Same thing here, nothing to worry about. What jumps out? This and this straight away. Parallel lines, you can see that Z shape. So it's here. My computer's a bit weird today. Right, anyway, there. So you should be a relationship between this angle and that angle, even these two angles. Yeah, now, alright, you'll figure that out. You should be able to figure that out. Right, I'm just going to move down. Let's go. Where is that? I'd like you to look at this. If you don't look at this and you mess up in the exam, well then. Alright, so I'm going to give you a different question here. I'm going to say A equals 3 to the power. Wow. Let's go with 7 then. My computer is just so weird today. 7 squared. It's actually the recording software. It puts like a massive toll on my computer's memory. Okay, so let's say A is 7 squared times 11 cubed. B is 5 squared times 7 times 11 squared. Okay, so we have to get the HCF. So what I would do, so that's the question you'll be given. I just expand them out. And there's a couple of shortcuts. There are a couple of shortcuts. Yeah, I'm just going to show you this way, and I might show you the shortcut way too. So that's a 7. So we're just going to expand that. 7 times 7, because 7 squared times. Actually, I'm not going to show you the shortcut because I don't want to confuse you. Times 11. Some students know the shortcut. Times 11. Bottom one is going to be 5 squared. That's 5 times 5 times 7 times 11 squared. Yeah. Times 11 times 11. Okay, fine. Now, let's do the HCF. HCF, so what's common? HCF equals. What's common? Let's start with smallest number 5. 5 on the bottom is 5 on the top? No, so that is not common, so we can't count that. 7 is the next biggest. We have a 7 on the bottom. Do we have a 7 on the top? Yes. So we can just cross that out. Right? We can cross that out. Done. Next, we have an 11 on the bottom. Do we have 11 on the top? Yes. So multiply by 11. Cross that out. Cross that out. Okay. And then what else do we have on the bottom? We have an 11 on the bottom here. Do we have 11 on the top? Yes. So we can use them. They're common. Done. Times 11. And that's it. Okay. So whatever that is. 7 11s is 77. So 770, you should get 847 when you do that. So the highest common factor is 847. That's it. Now, if you're asked for the LCM, just do this. Remember what we said about the LCM? LCM equals, it's the highest common factor times everything that's left. Yeah? So the highest common factor, HCF, was what? 8, sorry. What am I doing here? The highest common factor. What am I doing here? It's just this computer is really annoying me today. I can't get into a flow. So it's the HCF, which is 7 times 11 times 11 times everything that was left up above. Okay? So let's have a look. What was left? So we have a 5, 5, 7, and an 11. So a 5 and a 5. So multiply by 5. Now normally you would put this in numerical order. 5 times 5, and we have times 7 and times 11. Now everything is gone. Times 7 times 11. Right, I'm not doing that. I have a calculator on my phone here. So you're going to have 5 times 11 times, sorry, 7 times 11 times 11 times 5 times 5 times 7 times 11. So the answer is 1630475. Right? So that's 1630475. Only do this if you're asked the LCM. Yeah. Okay. Now, if they ask you to put it in index form, the top line would be, if they ask you in index form, top line would be, for the HCF, you're going to have 7 times 11 squared. Yeah. And for the bottom line, in index form, well, what's the smallest? 5. So you're going to have 5 squared, because we have 5 times 5. That's them 2 gone. Then we have 7 times 7, so that's times 7 squared, times 11, 1, 2, 3, 11 cubed. Yeah. Now, if you're very smart, you'll notice something. For the HCF, it's go here. It's 7 times 11 squared. What numbers are common between these two lines? It's 7 and 11, right? What's the lowest power of 7? Is it 7 squared or just 7? Just 7. What's the lowest power of 11 here? It's going to be 11 squared. Oh, that's how you get your HCF. It's the lowest power of the common factors. Now, the LCM, we 5 squared, 7 squared, and 11 cubed. So for the LCM, they don't have to be common, okay? So the factors don't have to be common. So it's literally the highest power of any number there. So we have a 5 here, it doesn't matter if it's not on the top, in this case. 5 here, the highest power is 2, 5 squared. 7 here, we have 7 here, what's the highest power? 2, it's that. 11 here, what's the highest power? 3, now it's that. Now, this can get tricky when you get into 3 numbers where we have to get the HCM and LCF. But so that's why I'd recommend this top line. Actually, when they do 3 numbers, I'd recommend you use Venn diagrams. Okay, if you see a worded question like this, both so Tom and Amy, they have alarms. When do the next sound together? Straight away, this is LCM. LCM. Okay? So Tom's alarm sounds every 9 minutes. Amy's sounds every 12 minutes. So we have 9 and we have 12. I'm going to change this to 90 and 40. 90 and 40. Okay, right, so I'm not doing this for you. 90, 40. What you do is you split it off factor trees. So you're going to have 2, 45, split it up, 5, 9, split that up, 3, 3. This one you're going to have 2 times 20, 2 times 10, 2 times 5. So we'll circle, I'll just circle the prime, 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 prime. So this is equal to what? 2 times 3 times 3 times 5 times 3 times 3 times 5. This one is 2 times 2 times 2 times 5. 2 times 2 times 2 times 5. So let's look at this. So let's look at the LCM. So the lowest common multiple. Okay, so first get the HCF. this is how we do it this time. HCF is going to be, so we have 2 and we have 2, so that's 2 times. Do we have 3 here? Do we have 3 up there? No. We have 5 here. Do we have 5 up there? Yeah, so that's it. Times 5. So the HCF is 2 times 5, which is 10, right? But we're looking for the LCM. LCM is equal to the HCF times everything that's left. Now, I'd say most of the other classes did this with Venn diagrams. But anyway, so let's do it. Everything that's left, well, we've 2 and 2. So it's going to be times 2 times 2. I'll move this across. Down to here. Now, what else do we have left? We have a 3 times 3. So times 3 times 3. So you just do that and you get your answer. So in index form, it will be 2 cubed times 3 squared times 5. But just as in terms of the actual number, so 2 cubed is 8. That's 9. So 8 times 9 is 72. 72 times 5 is 360, and that's your answer for the LCM. When you see this question, always LCM, LCM every time. Right, I'm gonna have to go soon. Common multiple. Write down a multiple of 6 that is between 50 and 40 and 50. I mean, write down a multiple, let's say a multiple of 8 that's between 90 and 100. Right, 90 and 100. How would you do that? Well, there's a couple of ways. You could keep adding 8s, you know what I mean? So, you know 80 is a multiple of 8, then what's next? 88, and then what? 96. That's between 90 and 100, so that's my answer. You're going to do the same here. So you, like, between 40 and 50, well, with 6, you should know that. You could go to 60 and then go back 6, and again, but it should be straightforward. Multiple of 8 should be very, very, factor of 50. A factor of 50 is a number that divides into 50. A prime number is a prime number that cannot be, it's a number that cannot be divided by any two distinct factors except one in itself. LCM of 8 and 2, 12, we just did that. Alright, yeah, this is LCM again. LCM, you have 20, you have 24, 24, split that up, 20, split that up, you'll get the factors, get the HCF, then get the LCM, straightforward. Again, this, now this time when it's 3, I would recommend doing Venn diagrams. Okay, this just, see what you're going to do, you have 20, 45 and 120, 20, you're going to split that up, you get some numbers. 45, you're going to split that up, you get some numbers, and then you have 120, so you're going to split that up and get some numbers. So what you'll do, you'll draw 3 circles. We did this last year. 3 circles, 20, 45, 120. Now, I don't know, let's say this was 2 times 2 times 5, and let's say this was 3 times 3 times 5, yeah, and let's say this one was 2 times 2 times 2 times 3 times 5. Let's just say that. Now I don't know if that's true, but let's just say that. What would we do in that case? Yeah, well, look for a number that's common between all of them. 2. Is 2 common between all of them? No. is 5 common between all of them? Yes. 1, 2, 3. So that 5 would go, if I had drawn this properly, that 5 would go in the middle. Okay, so I'll just draw it properly. So you're going to have this, you're going to have an ellipse, circle. Well, my computer is making this so difficult for me today. But then again, it's the recording, it's the screen recorder that's making it difficult, actually, not really my computer. Alright, that's a bit better. So what we're going to do is we're just going to populate this Venn diagram. Yeah, so we just said 5 is common to all of them. So 5 is going to go right in the middle of these because it's common to all of them. So let's say that's 20, that's 45, and this is 120. Then you get what is common to 20 and 120. So 2 is common just to 20 and 120. It says 2. What else? There's another 2. Yeah, that's common. And anything else? No, that's it. Now 45 and 120. What's common? 3. You just have 1, 3. That's it. And then 120, what's left? 2. And what's left for 45? 3. I've actually just done the question for you. So the LCM in this case is just all the numbers multiplied by each other, yeah? So you're going to get, what is that? A 2. 2 times 2, another 2 here, times 2, times 3, times 3, and times 5. I've just done the question for you. That equals 2 times 2 is 4, 4 times 2 is 8, times 3 is 24, times 3 is 72, times 5 is 360 again. So they're saying the smallest number that all of these divide into is 360. So in other words, what that means is after 360 seconds, they will flash again. So how many times in an hour? Yeah, so 360 seconds is how many minutes? You should know, you divide it by 60, so that's 6 minutes. How many minutes are in an hour? 60. So you're going to divide that by 6 and that will tell us 10 times. So they'll flash together 10 times in an hour. That's it. Alright, I really got to go soon. Should be able to do the nth term. Got to be able to do these. Like, please do not make a mistake on these. So we use our little technique. So here to here is what we add for. If you don't know the first one, just do the second one and the third one. 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13, right? So the second you do this, write down 4n. Yes, that's what you multiply by n. That's the first thing you do. Do not make this mistake. So many people make mistakes. Now you're going to go back 4. So it's minus 3, minus 4. You have a calculator. You have no excuse. It's going to be minus 7. That is it. 4n minus 7. Again here, what are we adding? Plus 5. Plus, once you establish that, plus 5, first thing you write down, 5n. Now, we're going to go back a step, isn't it? Minus 5. 3 minus 5 is minus 2. 5n minus 2, done. Alright, here, work out the fifth term. You might see that and it might look like Chinese. It's not. You have 3n squared minus 10. You're told to work out the fifth term. That means n equals 5. So you're going to say that equals 3 times 5 squared. Now it's the 5 that's squared, not the 3, yeah? Minus 10. 5 squared is 25. 3 times that is 75. Minus 10. So you should get 65 for that. I just did it for you. Okay. Anyway, that's it. Why did I just do that? Next one, n squared. So I'm going to do a different one. I'm going to do it for 2n squared minus 3. Yeah? We have to do it the first 3 terms. Okay. First one is n equals 1, n equals 2, n equals 3. So in our case here, you're going to have 2 times 1 squared minus 3. Next one, 2 times, replace the n with the number, this for this 2 minus 3. Next one, 2 times 3 squared minus 3. Why did I choose 1, 2, 3? Because you're asked for the first 3 terms. That's the first term, second term, third term. 1 squared is 1, times 2 is 2, minus 3 is minus 1. 2 squared is 4, times 2 is 8, minus 3 is 5. 3 squared is 9, times 2 is 18, minus 3 is 15. So the first 3 terms are 1, 5, and 15. Excuse me, minus 1, 5, and 15. This is not an arithmetic sequence, it's quadratic. 28, 128 is a term of this sequence. Which term? Alright, so you're going to put this formula, n squared plus 7 equals 128, and that'll tell you which term it is. So that was the formula that we're given in the question. So what you write down is this. We're told 128 is in it. So n squared plus 7 equals 128. Yeah? Then you're going to get n squared equals 128 minus 7, and then figure out n. I probably shouldn't have shown it anyway. Okay, we'll move on. Fibonacci, okay, let's get on with it. That's about it, alright? There's not too much more. Given that the third term is 7 and the sixth term is 29, find the value of a and b. This is just algebra. Okay, here's the first 3 terms of a Fibonacci sequence are this. Yeah, this is like 1, 2, 1 plus 2, right? What do you know about Fibonacci sequence? You just add the previous 2 terms, right? Don't we? Isn't that what we do? So let's say I said a Fibonacci sequence was x, y, x plus y, x, y, x plus y. So that's just like that, right? Now what's the next term? It's going to be x plus y, which equals x plus 2y. And then the next term, you're going to add these 2 together. Yeah? So you should be able to do that. Okay, I got to go. Technical difficulties, crazy. Anyway, hopefully some of that makes sense. I didn't want to make it too easy for you, otherwise there's no point in doing the questions. I ended up doing a couple of questions for you. Try to do them, put my video aside, try to do them without looking at the video. And then if you get the wrong answer, then look at the video. And try to do it later. Alright, thank you and adios.